Hello, you're welcome. So now before us is polynomials, equation and inequalities. Okay, so we're going to be treating this three in one topic. So we start with polynomial. What's a polynomial? Now a polynomial is an expression which is of the form, this form, right? Cn s raised power n plus Cn minus 1 s raised power n minus 1. Okay, so uh I will actually illustrate this expression. Now every polynomial always have a variable, and of course that variable is s. Okay, now one thing about a polynomial is that the power of the variable will always will reduce till the power of the variable becomes 1. So at this point, at the very first term of the polynomial, the variable being x, okay, has a power of n. Then at the second term, the power of the variable reduces by 1. At the third time, the power of the variable reduces by 2, okay, till the variable becomes 1. Okay, so invariably now for example, right, you have s raised power 4 plus 2 s raised power 3 plus s raised power 2 minus 2s plus 1. Okay, so this is a polynomial, and of course the highest power of the variable, okay, of the polynomial actually indicates the degree of the polynomial, right? So this polynomial now is a polynomial of degree 4 because the highest power of the variable is 4, and this polynomial is a polynomial of degree 3 because of the highest power of the variable is actually 3. Okay, now a polynomial is also expressed as a function. So all these polynomial you see here, they are all function, and the function a function in a particular variable, and the variable is x. Okay, so invariably now I can actually use, let me say, p of x to express a polynomial. Okay, so p of x, which simply means that this polynomial, okay, is a polynomial of function of x. So I have p of x raised power 3. Okay, p of s is equal to s raised power 3 plus 2x square, 2s square, right? Then minus 5x. Okay, then minus 6. Okay, so this is another way of expressing those. So this is a polynomial of in x. Okay, so the variable of this polynomial is actually x. Now a polynomial becomes an equation if that function is being equated to 0 or to another expression. Okay, if p of s is equal to 0, then we'll not simply say that this is a polynomial. Okay, this is an equation. All right, so anytime you are being asked to solve the equation, okay, in polynomials, invariably, all right, you are looking for the roots of the polynomial. The solutions to a polynomial, all right, is known as the root because it's not just one. So it is not just one solution. So we call that root of the equation, okay? Because a polynomial doesn't just give you one solution, all right? It will give you many solutions, all right? More than one solution. For example, this polynomial now of degree 3 will give you 3 solutions. That means the value of x that satisfies this equation, all right, is gonna be 3. So three values, or three values of x, okay, is what will definitely satisfy this equation. And what do I mean the value of x that will satisfy this equation? The value of x that will satisfy this equation is actually the value of x that, if I put it into this expression, it should be equal to 0. Okay, so now, for example, now let's say a situation where you are being asked, okay, uh let's say in this same polynomial, you are being asked to investigate if 3, okay, to check if 3 is the root, okay, is the root of this polynomial. Is 3 the root? Okay, so how do I do that? For me to be able to check if 3 is the root, if I should evaluate p of 3, okay, if I evaluate p of 3, that means any place I see x in this polynomial, I put 3. Then if it gives me 0, that simply means that 3 is the root of that polynomial. All right, now let's look at that. Let's see if that actually is possible. Okay, so let's put 3 into the expression. That's going to be 3 raised power 3, then plus 2 times 3 raised to the power of 2, then minus 5 into 3, okay, All right, and then of course minus 6. All right, so let's see what that yields. This is gonna be 27, okay? And of course this is gonna be equal to 3 raised to power 2 is 9. 9 times 2 is 18. Oh, this is gonna give me 15, and this is gonna give me minus 6. Okay, so if you use your calculator to actually evaluate everything that I have here, use calculator, you will end up having 24. And of course 24 is not equal to 0, so invariably, okay, 3 is not the roots, okay, of that polynomial above. But let's actually let's check another value of x. Okay, let's investigate x being equal to minus 1. That means invariably now we are doing p of minus 1. So I'm going to have minus 1 raised to the power of 3, then plus 2 into minus 1 raised to the power of 2, then minus 5 times minus 1. Okay, then minus 6. Let's see what that yields. Minus 1 raised to the power 3 should give me minus 1, because minus 1 raised to the power 3 is minus 1 times minus 1, which is plus 1. Plus 1 times minus 1, that's minus 1, right? Okay, so then of course minus 1 raised to the power 2, that's 1. 1 times 2 is 2. Minus 5. 5 times minus 1, that's minus 5. Minus 1 times minus into minus, of course you should know that is plus. So what I'm going to have here is plus 5, right? Then minus 6. So let's try this now. Minus 1 plus 2, that's going to give me minus 1. 5 minus 6 is minus 1 plus 2 is 1, right? This is 1 here, and this is minus 1. Okay, then of course 1 minus 1, that gives me 0. So that simply means that x, okay, equal to minus 1 is the roots, is one of the roots of that polynomial, just one root. Okay, so if x equal to minus 1 is 0, that means x, if I should take this minus 1 to the other side of the equation, okay, x plus 1, okay, is actually a factor. Okay, now we're going to talk about factor of a polynomial in a jiffy. So I hope that is well understood. All right, so what are we going to be looking at next? Okay, let me clear up my screen so that we proceed. So we are going to be looking at division of polynomial, and of course the factor. All right, division of polynomial. Okay, anytime a polynomial is being divided by another polynomial, okay, what you have is a quotient and a remainder. Now let me tell you what I mean. For example, you have a polynomial which of course is a polynomial in x, right? Now it's being divided by another polynomial, let's say a divisor. If we do this division, okay, the same way we actually do normal division, you will have a result, all right? Known as a quotient. The result of your division is called the quotient, all right? The result of your division is called the quotient. Then you will now end up having a remainder, right? Plus remainder. Remember, your remainder is always all over the divisor. Okay, this is just this shouldn't be a kind of a rocket science, because let's look at, for example, when you have 3 all over 2. Okay, if you divide 3 all over 2, you have one whole number, right? and the remainder is 1 over 2. So the same thing happens with a polynomial. When you divide with a polynomial, you still have, okay, you still have that. Okay, but there's one thing you should know. This r of x, this is a polynomial, also known as the remainder. That is what is left, okay, after division. Now, if the remainder is 0, if you don't have any remainder after the division, okay, because there's some instances after you divide the polynomial by another polynomial, you will not have any remainder. So if the remainder is equal to 0, that simply means that what you use in dividing that polynomial is a factor. That means d of x, okay, is what is the factor of the polynomial. So d of x is definitely the factor of p of x. So anytime you divide a polynomial, okay, by another polynomial and you don't have any remainder, then that polynomial, the divisor, becomes a factor of the polynomial. Now, let's look at how we actually divide polynomial, okay, by a process of long division. Now, long division is what you must have actually, okay, practiced before, but not with polynomial. I'm very sure it's with numbers, all right? So in dividing a polynomial by long division, okay, we'll actually, first of all, write the long division symbol. This is where we put our dividend, and this is where we put our divisor. Let's look at a situation where you are being given a polynomial of x raised to the power 3. X raised to the power of 3, then plus 6x 6x squared minus x, then minus 30. Now I have to divide these polynomials by another polynomial, which of course is x plus 1. Okay, so that's exactly what you're going to do now. Let's do this division. Now I'm going to actually write the steps that you take in dividing a polynomial. The very first step is in sequence. First of all, you divide. Okay, you divide. The next step is you subtract after dividing. No, you divide, please pardon me. You divide first. After dividing, you multiply before subtracting. Okay, so divide is the first step. The next step is multiply. Then of course, then you now subtract. All right, so and our division is going to be basically with the variables, okay, but multiplication is going to be with everything. So let's start. So the very first thing I'm going to do, I'm going to start with the very first term here, which is x raised to the power 3 divided by x. Okay, I'm only concerned with the first term as I divide and subtract, so that at the end of the day I'll keep on going, okay, through this sequence until I have my final remainder. Okay, so let's start. X raised to the power 3 divided by x. You know very well that what I will have is s squared. So I have divided, then I now multiply s square multiplied by x. Of course, that's gonna be s cube, right? S square multiplied by 1, because I have to multiply everything. Okay, s square multiplied by 1, that gives me s square. So I'm done with multiply. Then the next is subtraction. Then I now subtract what I have, okay, to have a new polynomial. So let's subtract s cube minus s cube, that gives me 0. Then 6s square minus 1s square, that gives me 5s square. Of course, minus x minus 0, that's still going to be minus x. Minus 30 minus 0, that's still going to be minus 30. Okay, so let's divide again. Okay, so the next division, I'm having 5s squared divided by x. All right, of course, you're gonna have, that's gonna be plus, right? Plus 5x. Divide sequence. Then the next is I'm gonna multiply 5x multiplied by x. That gives me 5s squared. The same 5x multiplied by plus 1, I'm having 5x All right. Then the next sequence I multiply, then I now have to subtract again. Subtracting, okay, that's minus here. 5x squared minus 5x squared, that's 0. Then I'm having minus 5x minus, because minus into plus here is minus, right? Minus x, please pardon me, minus x minus 5x, okay? That will give me minus 6x, all right? Then minus 30 minus 0, that gives me minus 30. All right, so I have subtracted, then I now go over again. Divide, so I'm dividing minus 6x by x. That's gonna give me minus 6, okay? Then I now have to multiply minus 6 multiplied by x, so that gives me minus 6x. All right, and minus 6 multiplied by minus 1, that gives me minus 6 multiplied by plus 1, please pardon me, that is minus 6. Then I can now subtract now finally, okay? So if I subtract minus 6 minus into minus, minus is plus, right? So minus 6 plus 6x, that is 0. Then my final remainder now will be, because all my x are gone, so I'm going to have minus 30, minus into minus, right? That's plus, minus 30 plus 6, and that should give me minus 24. So invariably now, so the remainder of dividing this polynomial is minus 24. And my result that I got is s squared plus 5s minus 6. So my result, my quotient of this polynomial is s squared plus 5s minus 6. Okay, so I hope that is well understood. It's a very simple sequence, okay? All right. Now, so I would have actually given you more example, right? But we will do that in another video. But let's look at another subtopic, right? Let's look at another subtopic. Okay. Okay, so here we're going to be looking at what is known as the remainder theory. Remainder theorem, as the name implies, okay, actually help us to, it's a theorem that helps us to find the remainder of the division of a polynomial. So we're looking at the remainder theorem. So I hope you're with me. So remember, anytime you divide a polynomial, definitely you have a quotient and a remainder, okay? Now, and what if you are being asked to find the remainder of a division of a polynomial? That simply means that by normal convention, you have to go through the division, right, to arrive at the remainder. But there's another method, a very simple and fast approach to it, and that is the remainder theorem, okay? Now, what's the remainder theorem? What does it state? Now, according to the remainder theorem, anytime a polynomial, okay, p of x, anytime I have a polynomial p of x is being divided by another polynomial, let's say x of s minus a, okay? Then the remainder of this division, right? The remainder of the division, r of x, is gotten directly by just evaluating uh, p of, excuse me, by just evaluating the p of a. Of course, you know what I mean by p of a. P of a is the value of the polynomial when you replace x by a, okay? So to get remainder, so you get it directly without even going through the division by doing p of a. That is how I can get my remainder if p of s is being divided by x minus a. Okay, don't worry if that doesn't make sense. As an example now, we'll make it to make sense. Now I can actually probably prove that what we got previously, okay, remember what we got previously when when we divided this polynomial p of x, okay, p of x being equal to x cubed. That was what we did previously, okay, x cubed plus 6x squared plus 6x squared minus x, then minus 30. All right. Okay, so remember we actually divided this polynomial um, by a factor, okay, by d of x, which of course is simply we divided it by that just that was x plus 1, if you can still remember. Okay, so and we got a remainder of minus 24. So let's actually use that to confirm that our remainder theorem actually works. Okay, so if I want to get this remainder directly without going through the division, okay, then all I just need to do is just to do f of a. How do I even find what a is? Okay, now let me give you just a very simple approach. If you want to find what you would replace the a, just simply do x plus 1, okay, being equal to equate it to 0, so that you can get your x now to be equal to minus 1. Okay, so invariably now once you got in your x to be equal to minus 1, you can now get your remainder. Your remainder is simply going to be the p of minus 1. That's all. That's just all. All right, so let's put the value there. That's going to be minus 1 into what we have here. Okay, so that's going to be minus 1 x power 3, because I'm doing p of minus 1. So any place I see s, I do minus 1. Okay, so then plus 6 into minus 1, then minus, please pardon me, okay, 6 into minus 1. All right, then minus into minus 1, then minus 30. Okay, so let's do this now. Let's see what we have. Of course, this is going to be minus 1. Okay, this is going to be minus 6. Okay. Okay, yeah. Okay, this wasn't the original polynomial. Okay, I actually am using another polynomial. Please pardon me. Okay, this wasn't the original polynomial. All right, so but let's still all the same. Let's still get to the end of this. All right, this of course minus minus here. That's gonna be minus times minus that's plus. Okay, plus 1 and minus 30. All right, so let's do this. This is gonna be minus 7 plus 1, and that's gonna be minus 6. The minus 6. Okay, so let's do that again. This is minus 1. Okay, minus 6 plus 1 minus 30. Okay, so now let's do this. So I'm gonna have minus 1. Good. Then I have, okay, my bad, minus 1. This is 6s squared minus 1 all square, right? My bad. Okay, please pardon me. Then of course minus 1 square, all right, is plus, so definitely what I should have here is plus. Okay, and that is it. Okay, and here is plus 1, quite well. All right, so let's do this now. So what I'm having is minus 1 plus 1, that is 0. Then 6 minus 30, that is minus 24. Okay, all right, so I think that is it. That is the polynomial. Okay, so I hope you understand the logic behind this. That's what is very important. So understand the logic behind it. Okay, so I could actually probably bring just one example, one more example, then we look at that. Let's look at um okay, let's look at now what we did previously, right? Let's look at the division of x raised to the power of 3, x raised to the power of 3 plus 2s squared plus 2s squared, then minus 5x, then of course minus 6 by x minus 3. Okay, so we're looking for the remainder, right? The remainder, of course, is going to be equal to, of course, you know very well that if I want to get the value of x minus 3, okay, is equal to 0. So for me to get x now, this is going to be s is equal to 3. So to get this remainder, I'm going to have I'll do p of 3. So any place I see x, I'm putting 3. That's going to be 3 raised to the power 3, right? Then of course plus 2 into 3 raised to the power of 2. Okay, then minus 5 into 3, then minus 6. Okay, so this should give me 27, and of course this should give me 9. That's gonna be 18. This should give me minus 15, and this will give me minus 6. So if I should do this, of course I will have use calculator to do this. You have 24. Okay, so I hope that is well understood. So that is remainder theorem. Okay, so we are going to be looking at factor theorem in the next video. Factor theorem. So we use factor theorem, okay, to investigate if a polynomial is a factor of another polynomial. So see you in the next video. Thank you very much.